So yes, I'm looking at the effects of image degradation and manipulation on computer vision analysis. This work was also helped with by Tom Kumar in both from the Open Observatory in the School of Engineering at Newcastle University. So the sort of contents for this presentation, I'm going to start off with a bit of background to my project and the wider work that I'm doing, sort of give it a bit of context. Then I'll move on to why this work is important, go through a methodology, some results, and then some acknowledgements. So first of all, a bit of wider sort of context for this research. So my wider PhD is based on modelling the city from the kitchen to the national grid, looking at multi-scale Internet of Things monitoring data. So a little bit about me quickly. So I'm a second year PhD student with a background in GIS from Newcastle University. And as I said before, I'm based in the Open Observatory at Newcastle University. A bit about the Open Observatory, just so you know what facility I'm working with. So they've got lots of observations from the city and smart buildings in Newcastle. They've got open weather data, air quality data. They've got data on footfall. They're getting data from horses in Northumberland National Park. They're getting data on sound levels, all sorts of different information. So there's a really good setup there for me to work with and integrate this IoT work with. This is a quick example of the sort of work that they do. So you can see they've also got traffic CCTV data and things like that. A bit more on my project itself. So there's been lots of technical development in recent years into Internet of Things monitoring, but generally all these systems operate independently as so-called IoT islands. There's not much interconnection between these systems. And also I'm focusing more on people movement data because currently a lot of movement monitoring is focused on public transport to try and optimize traffic flows. And it often overlooks that finer scale people movement, which is essential as people might use public transport during the main part of the journey, but if those got to travel at either end, and also if they're just traveling through a city centre, there's a good chance they won't take public transport and they'll just walk. So this quote, I think, quite nicely sums up the reasoning for this research. So Tim Berners-Lee, who invented the World Wide Web, said that we should be working towards a universal linked information system in which general reality and portability are more important than fancy graphics and complex extra facilities. So I think this means it's more important to have these systems interconnected than have each one having fancy displays and dashboards and a little bit of extra data. And it's much more powerful if these systems are interconnected. So my project aims to monitor people movement at different scales across the city, with particular focus on transitional spaces in order to inform operational usage and design and planning of spaces, be that office buildings, train stations, etc. So actually moving on to the work I'm presenting today, looking at the effects of image degradation and manipulation in computer vision analysis. This work's really important because computer vision analysis is becoming more commonplace, especially in the geospatial domain. And CCTV data is classed as personal data under GDPR. What this means is that it must be encrypted when transmitted and stored safely. The problem with encryption is nothing's 100% foolproof. It can always be cracked. So it might take time, but it can always be cracked. So what I'm looking at is if we can degrade the images to a certain extent, yet still perform the analysis with a reasonable level of accuracy, such that even if the data is encryption is cracked, then the images aren't useful to anyone trying to steal personal data. As some context as to why CCTV data is used in geospatial domain. So you can be collecting footfall data, which I know a lot of previous presentations have been talking about using. dwell time data. So that could be how long someone stays on the street for, or how long they're outside a certain shop for. It could be traffic counting to understand how traffic moves around the city. Could be looking at space usage or occupancy monitoring, be that how many people are in an office or public building, or how many people are off into a train station or into a car park. Also, something that's come around because of COVID-19 is looking at social and physical distancing. You'll see in the bottom picture on the screen that some work that Tom's been doing in the Upper Observatory, looking at how we can look at physical distancing in public streets. And this is also some work that I'm looking at developing. So data collection for this research was done using a fisheye camera placed above the observatory's office with 4 different views. I manually labelled images with 2 different classes of heads and persons, and had over 2,000 labels across over 700 images, and set aside 5% of those images and labels for validation data. So the actual methods that I used for grading and manipulating the images were 3 different methods. So the first of these was reducing the resolution or resizing the image. As you can see demonstrated in the picture, the bottom one is of the lower quality. I apologise, it might not show up too well on this PowerPoint, but trust me, it is lower resolution. I also looked at representing the image in a hue saturation value color model, and also using edge detection or contour method. So the HSV model can be a bit confusing to understand what I'm doing with, so I'll try and explain that in a bit more detail. You can see this image here as to what a typical frame from a camera might look like once this has been applied. It's worth saying it can almost be reversed, but you're not quite able to form one-to-one matches to reverse it due to varying resolutions of the colour models being used. But whilst that might mean it's not ideal for data when it's being transmitted, it's ideal for if you're trying to train data and draw labels around it, and someone might be passing by if you're doing that in an area that isn't necessarily physically secure from other people. So this is some of the maths behind how I did this. So first of all, so the first 3 columns are converting it into HSV, and then from there I had to represent that in red, green and blue colour model, such that the computer actually understood it and the models understood it. As a worked example through here, I took a colour from the Gisrook logo and worked through this example, so you could see that first of all sort of normalized the data into range, and then worked out the maximum and minimum for each value and a difference for the maximum and minimum for each band. Sorry, which band was maximum and minimum for each pixel value, and also the difference between the maximum and minimum band. From there, you could calculate the hue, the saturation, and value numbers, and then convert these back into a red, green, and blue. Because that's not necessarily the easiest to understand, here's a visually worked out example to show you how the sort of light sea green colour from the Gisrook logo might go into a more riptide colour. The other method being used was a contour edge detection method. This has the benefits of it produces a grayscale single band image, which has benefits if you're trying to transmit the data in that it uses a lot less bandwidth. It's worth noting that a lot of noise might remain in the image depending on the parameters used. This might be things like the carpets or finishes on tables and stuff. So now that I've discussed how we degraded and manipulated the images, I'm going to talk about how we trained the model. So I used a TensorFlow framework and used a faster region-based convolutional neural network approach. I used this because I thought it was a good balance between both speed and accuracy. I started with the Microsoft Cocoa as the starting basis and trained the models to both 50,000 steps and later to 200,000 steps when I had more time and resources. And understood comparison between what both steps produce. So as some results, here you can see tables showing the precision of each model at the different training steps, grouped by class, each class, so the head and the combined, head, person, and also combined results. So I'm going to now talk through some of the important results I found in here. So first of all, Contours produced the best results of the degraded and manipulated images in both 50,000 training steps and 200,000 training steps. One of the Contour results, so when there were more training steps used, actually produced a better result than the modified version by 3.1% points. Whether that's an sort of anomaly, it's yet to be determined. It's potential that there's some bias in the data with it being in a single office with the same people being in that environment all the time, potentially in the same location. I'll come on to how I'm going to improve that work going forwards as well. The resized heads class attained the lowest percent in both tables. This is likely because when it's downsampled, as it goes through the convolutional and pooling layers of the faster RCNN network, the smallest heads, which are potentially about 10 pixels in area, disappear from the feature space. The HSV model improved dramatically when I increased the training steps. So that shows that it is important to use more training steps when you're producing these models. So there was an overall increase of 4.5% points, and the heads improved even more so by 7% points. In conclusion, both the Contour and HSV produced similar results, both obtaining a reasonable level of precision. The reduced resolution has the least accuracy, and that just shows why having a higher resolution image is always a good starting point. The HSV one, as I said before, is almost fully reversible. So overall, I would conclude that the Contours is the best overall method, both for accuracy and security. And as I said, there's also the added benefits of if you're trying to transmit it over a network, if you're doing that processing at the edge, which you should be if this is about trying to secure transmitted data, it reduces the bandwidth a lot. For future work that I've got planned, firstly, I plan to use a more diverse training data set with more images. I'm currently just waiting for the resources to actually be able to accomplish this. Unfortunately, COVID-19 slowed that down. And also perform sensitivity analysis on the methods used to determine if different parameters with the Contours or different resizing factors, etc., might alter the end results. I'd like to thank the Open Observatory Group, Newcastle University, for their support, especially to Tom Umar, who co-authored this paper, not technically with it, and also to Luke Smith, who helped with the ethics side of things, and also to the Secure and Resilient Systems group at the university that have been involved with as well. I'd also like to thank UKRI and the Ordnance Survey for helping fund this project. And also finally my supervisors, Phil James, Charles Morissette and Jeremy Morley, for continued support throughout this project. Thank you. Any questions?
Thank you very much, Tim. That's interesting and very important topic on there. So if people can put questions into the chat, we've got about 10 minutes left for the break. So maybe I can start with a question. You decided to collect your own training data set, and I imagine there was quite a lot of work involved in the labeling of those images. Why didn't you decide to use one of the publicly available image data sets to train your model?
So I was specifically wanting to look at this data in office environments, and I was deploying these cameras for future work as well. So I decided to use that. What I'm looking to do going forward as part of my future work is use open source data. So I've realised that there's potentially some bias on this.
So do you think that your method would work differently in the office environment to how it would in, say, an open public space like a train station?
I would hope they would both work the same. Obviously, I can't say for certain without having tested it. But some of the open source data I'm looking to use is some newly released data by the Open Observatory through a pitching project, which is all about trying to produce large-scale open source labeled training data for this sort of work. And that's being collected from different traffic cameras across the Northeast.
Okay, so keep those questions coming in the chat. I was wondering, so you trained your model on static images or on the video? So do you do tracking at all between the
At the
images?
moment, this was just based on static images. I'm looking at moving this forwards to doing it with tracking as well. So I'm looking at doing some work going forwards on social distancing inside an office environment. So that'll involve videos and tracking tool frames as well.
Yeah, I think that's a very very important topic at the moment, and something that's going to be probably important for quite a while. How do we measure social distancing, perhaps? How does that then link to policy and providing alerts, for example? The other thing I noticed was the quality of your images was quite high, seemed to be quite high resolution. So I don't know whether you said out whether you could apply this to lower resolution data that you might get from, say, CCTV.
Yeah, so that's part of why I included the resized images in there, just to try and account for the fact that they won't all be that resolution to see what that effect is. And I think it showed that the higher resolution it is, the much higher precision you can get from this sort of work.
Okay, so we got a question here from Sarah Wise. So how much computation time is involved, and how close are you being able to run something like this live?
So training them took, each one I think took about 18 hours to train, up to 200,000 steps. How close am I to running this live? I think it should be possible to run this live, and this is what my future work is looking at doing, because I'm looking at previously preserving social distancing data. I haven't tried running this live, but it's just a case of doing the pre-processing on the data, which could be performed at the edge, since it's like a Raspberry Pi connected to a camera. So it should be possible to do it live.
Yeah, so once the model's trained, that's the bulk of the computational work done, right?
Yeah, that's correct.
Okay, so we've still got about 5 minutes left. So keep questions coming in. So you mentioned, so you're working with Ordnance Survey and they're planning to use this operationally, are they?
So my PhD as a whole is sponsored by Ordnance Survey. I've had some discussions with how this could potentially be used. There's no plans as of yet, but I'm in talks with them for my PhD project.
Mm-hmm. That's a really interesting project. So how far into your PhD did you say you were?
I'm towards the end of my second year at the moment.
Okay.
Unfortunately,
I
there's
think
a
it's a
lot
really interesting.
involved with this sort of thing.
Okay, so we have another question from Fuad. So are there plans to build software to make available to people so that they can analyze their own data?
At the moment, no. It could be something that I'll look into doing, but at the moment, there's no plans for that.
Okay, so thank you very much for that, Tim. There's no more questions coming through right now, but I think it's a really interesting project and something that's become even more topical with the current COVID-19 situation. So I wish you best of luck with your ongoing PhD. One more question coming through from Stephen. Have you thought about combining low-res edge contour and low-res image to capture both shape and texture in a low setting?
I haven't looked at that. That's definitely a good idea, and I'll look at doing that in my future work, I think. That's something that might be important in the sensitivity analysis to look at what it's like when I combine these. At the moment, I'm just waiting for extra processing resources to actually be able to perform this type of work.